Okay, so now we're concept 2, number 2. Problem number 2. Okay? So a student throws his worthless lab partner off a 240-meter high bridge with an initial downward speed of 8 meters per second. So it's asking, and then it asks how long it takes for them to hit the ground. So you can use the formula, change displacements equals 1/2 AT squared plus VIT. Okay, so you're looking for the change in x, the vertical change in x, so that equals 1/2, and since we're dealing with the vertical components, it'll be 10 meters per second squared times the time that it takes, which is t, and actually we do have the displacement. It is, sorry about that, it's 240 meters. Okay. So the time squared plus the initial velocity, which is 8 meters per second, multiplied by the time again. Okay? So if you move it all to one side, 0 equals 10 meters per second squared times, oh, sorry, that's 5 meters per second squared. 5 meters per second squared times the time, which is also squared, plus 8 meters per second times time minus 240 meters. Okay? And so then if you solve it out, then the time can equal 6.174 seconds, or negative 7.774 seconds. And so we know that it's not going to be a negative time, so it will be the 6.174 seconds. Okay. And then it asks what speed he'll be at his impact. And so to do that, you would do velocity final squared equals velocity initial squared plus 2a change in x. Okay, so velocity final squared equals, again we're dealing with the vertical components, so it will be 8 meters per second, that quantity squared, plus 2 times 10 meters per second squared, which is gravity, times 240 meters. See that all? Yeah. Okay. So once you do that, you can do velocity final squared equals 4,864 meters squared per second squared. So velocity final equals the square root of that. So it equals 69.742 meters per second. Oh, here, one sec. There we go. So that's it.